Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge on the medium challenge section called the add two numbers. And for this particular challenge, we are using the TypeScript as our language, but if you want to use something else other than TypeScript, then go ahead. And for this challenge, we are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. And the two numbers add the two numbers and return the sum as a linked list. You may assume that the two numbers do not contain any leading zero except the number 0 itself. And for this example 1, we have the input called the L1 or the linked list number 1. We have 2, 4, and 3. And for the linked list 2, we have 5, 6, and 4. And the output, it says 7, 0, and 8. But explanation, it is in reverse because it is a linked list. So the challenge says it is starting from reverse or from the back. The last digit, it's starting from the back, which is 2 right here, and also the 5 on the linked list number 2, and the result is 7, which is the sum of 2 and 5. And what about the other one, which is the middle part, the middle digit? We have 4 and 6, and then we got 0. And then for the next one, 3, 4, and then we get 8. Why is it 8 instead of 7? It's because we have some kind of carry mechanism to carry the value from the sum from the linked list 1 of the index 2 right here, which is 4, and for the next one, which is the number 6. And then since 4 added by 6 is equal 10, then of course we only assign the last digit or the second digit as 0 and the carrier as 1. And then 1 will be added by 3 and it is 4, and then 4 added by 4 is equals to 8. So that explains the answer in a reverse visualization of linked list. And for the example number 2, we have both 0 as the node, and then the calculation of the both 0, we have new constructor of the linked list of the data or the value that described on the commented section of the class list node, which has the value property of 0, and the next property is of course on null. For the example number 3, this is the complicated one. We have linked list 1 consisting of 7 digits or 7 nodes of all 9s, and then the linked list 2, we only have 4 digits of all 9s, and the output, it says 8, 9, 9, 9, 9. It's only 3 9s and then 3 zeros and then 1. It is because since 9 is adding by 9, we have 18, and then the rest of the calculation still 18, but then with the carry of 1, and then we get the 19, also 19. And since linked list 2 is already empty, then of course we should not stop the iteration because linked list 1 is still iterating of the 9 right here. Since the 1 is the carrier, then of course we are adding 1 with 9, and we got 10 as our answer and assign to the new linked list node with the constructor class. And then for the next one, we still got the 10, we still got the 10 again. And then for the 8th iteration after outside of the linked list 1, since linked list 1 is already empty, already null of the next, then of course we are returning the remainder of the carrier as our new node with 1 right here as the last node of the linked list output. And we have the constraint, the number of nodes in each linked list is in the range between 1 until 100. So the maximum nodes from the linked list 1 or linked list 2 is either 1 until 100 of nodes. And of course the constraint number 2, we have the node value inclusive 0 until 9. So it means that we only have between 0 and 9 inclusive. 9 is included and 0 is also included as the possible value from the either linked list 1 or either linked list 2 or both of them. It is guaranteed that the list represents a number that does not have leading zeros, as explained from the example number 3 right here as our answer, because linked list 2 only has 4 nodes and the linked list 1 has 7 nodes. So that way we are returning 8 nodes because we have extra 1 as the carry value. Okay, so let's solve this. We have the function of add two numbers that contains two parameters of the linked list 1 in a form of linked list node or null, and so the linked list 2 in a form of linked list node or null, and the output is either linked list node or in a form of null value. So let's, for the first one, let's see using the console.log. Since we are using the TypeScript or JavaScript, we can see the linked list 1, the console.log linked list 2, and then return null for now. And so let's run the code to see what is it about. And we have the standard output just like the question or the parameter of linked list 1 or linked list 2, and the expected output is 0, 0, and 8, just like on the example number 1. And also the same thing goes on the case 2 and also the case 3. Okay, the case 3 is more complicated, just like on the example 3 right here. So let's solve this together. First one, we have to create a constant called the new node that takes a new node constructor called the, what is the name again? Let's close the test result and construct our new node called the list node, and then we can assign 0. Why is it 0? That way we are assigning just a temporary new node, because a constructor always carries a value, because we also cannot insert we cannot just assign a new value using the value property as the calculation from both linked list 1 and 2 value and the linked list 2 value. And then we're assigning 0 with the next, which is represented by the arrow right here, with next property as the next property. And then for the next one, we can simply declare our constant again called the current node that takes the new node. You might be wondering why we are assigning two variables all at once. It is the current node acting as the pointer from the new node, already declared new node constructor right here, and we can assign this using the current node. That is the raw visualization of what we are trying to solve here. So for the next one, we can simply declare our value called the let variable called the carry, and this one is used to carry the calculation. Let's say we, from the example 1, we have 4 right here calculated with the node on the second node of the linked list 2, we have 6, and of course the carry will carry 1, and since the answer is 10, then of course we are assigning 0 as the list node of the second list node. And then we can check if either linked list 1 is not null and linked list 2 is also not null. We can simply declare a while loop while linked list 1 is not null using the strictly equal, or linked list 2 is also not null. And then we can check from the example 3 right here, since linked list 2 only has 4 nodes, then of course we can add a check, and the linked list 2 nodes amount is not equals as the linked list 1 nodes amount. And also for the parameter here, it is possible that the linked list 1 parameter has either nodes, linked list node, or null. And also the same thing goes on to the linked list 2. To solve this edge case, we can simply declare an if check. If the linked list 1 is null, then using the exclamation mark notation in the front of the variable to check if it is null, then we can simply assign our value. Let me declare node 1 or node 1 as 0 value. If linked list 1 is null, then of course we can assign node 1 as 0 again, and we can declare the let in front of it, don't forget. And to simplify this, we can assign just like this if you want, but for this video I'm going to use a ternary operator. We can check if the linked list 1 is null using the not the exclamation mark. If it's not null, if it's there, has the value, is not null, then of course we can assign the linked list 1 dot value, assigning the value property. If it is null, then of course we can assign 0 after the colon sign right here. If it is not null, then we can assign after the question mark, and the opposite is after the colon mark. And also the same thing goes to the let node 2. We can check if node 2 is not null, then of course we can assign the using the value property and assign this as the node 2 value. If it's null, if the node is null itself, then of course we are assigning 0 as our value. And then we can simply use the constant sum to calculate the carry, sum between nodes plus carry, the carry that we already declared right here. The initial value is 0, then we can assign the node 1 as we already declared on above, and then with node 2, and then with carry. And then we can reassign our carry like this one if it is, since it has the carry of 1 from the first node iteration, and then for the next node we have the value of 19, it is still a carry, then of course we can assign the carry again using the carry equals the sum divided by 10, and then the sum is divided by 10 is of course has the possible value of the floating value or a return value with comma. To get around this, we can simply assign the using the Math.floor, and then we can only returning either 1 or 0. Let's say we have sum of 10, since 10 divided by 10 is equals to 1, then of course we have the carry of 1, and then we are returning the assigning the node with 0. If it is 11, then of course the sum divided by 10, 11 divided by 10 is equals to 1.1, and then 1.1 will be using the Math.floor, be filtered with the Math.floor, and then we only returning 1 instead of the remainder of after the comma sign. We are eliminating 0.1 from our Math.floor calculation. For the next one, we can assign the sum to the node, to the new node. Using the constructor, of course, we can use the current node instead of the new node.next, because we are using the current node as our pointer right here, that this is the one that moves forward to iterate over the new node instead of new node itself. We can assign the current node.next, and then we can assign the new node, new list node, sorry, it is list node, and then we can assign the sum with the modulo of 10. Why modulo 10? Let's say we have the sum of 10 modulo by 10, or 10 divided by 10 doesn't have any remainder, then of course we are returning 0. If it is 11 divided by 10, we have the remainder of 1. It is because 11, the nearest sum from the division right here, it is 10, then of course 1 is assigned as the remainder, then of course we are assigning only the last digit from the list node, and the carry will be assigned as the carry right here. That way we are dividing the first digit as the carry and the last digit as the next node. If it doesn't contain any carry, then of course we are assigning carry as 0, and still the next current node will be from 0, either from 0 or until 9. And then for the next one, we can check if the linked list 1.next is there or not null, then of course we are assigning linked list 1. We can add a check. Let me describe this. Check if either nodes next property is not null. It is used to anticipate if the next node is null. If it is not null, then of course we are moving the current node iteration to the next one. If it is null, then of course we can stop right here. We can assign like this linked list 1 to the next, and of course the next one we can check if linked list 2 dot next is there, then of course we are assigning linked list 2 with the linked list 2 dot next, moving to the next pointer using the next property right here. And then for the last check, don't forget, since the last one right here, we are assigning the carry as our new node. Since linked list 1 is already depleted and also linked list 2 is already iterated, then of course this is the calculation from both lists. Then we are assigning an extra node as the node from the carry value. We can assign if the carry is above 0, then of course we are assigning the current node dot next with the new list node, just like on the while loop using the carry value. Then of course we are returning. If you remember from the first one, we have the 0 as our new node right here, because it is not possible to assign the value property directly. So instead we assign, or we construct a new list node class as the first node. Since 0 is not used as the answer, then of course we can eliminate 0, and then we can only assign the next one after the 0, which is from the while loop operation, and also from the if carry check if it has a carry. If it's not, then of course we are not assigning a new node as the last node using the carry. Then of course we can use return of the new node. Don't forget, it is a new node instead of the current node. New node dot next. That way we are eliminating 0 from our answer. And don't forget, let me describe this one. If carry is still there, and return only our answer instead of placeholder node 0. And for the next one, don't forget to iterate our current node dot next, because we are iterating using the while loop right here and moving the linked list 1 dot next and also linked list 2 dot next if it's still there of the next property. And we are assigning the current node dot next. So let's run this to see if it works. And we have cannot assign the current node because it is a constant. Yes, the linked list operation is also requires a non-constant variable to iterate over the current node using the current node dot next. Since we are accessing the next property, and of course that way we are ultimately replacing the state of the current linked list iteration with the new one. Then of course we are going to use the let instead of the constant of the current node to iterate over the nodes from the linked list chain. So let's run this again to see if it works, if it truly works. And we have time limit exceeded. Maybe it is because the linked list 1 or linked list 2 check if it is not null. Let's say what about we are assigning the using the next is not equals to null, then of course we are assigning that one. Also for the linked list 2 is not equals to null of the next property. Let's run this again. Okay, what about eliminating this one? Don't worry, we are just trying here. Okay, it is accepted. What about the next cases? Yep, we have 0001. It is iterating properly. So let's run the code to see if it works. Submitting this one. And we have the runtime of 2 milliseconds and the memory runtime of 61 megabyte memory allocation, because we are not assigning the console.log anymore, and we are assigning the carry as our variable. Yeah, we have so many variables we assign. Okay, so that's about it. I hope you understand my explanation. If you still understand, of course, not people will understand or grasping the knowledge immediately. Of course, we are still learning. Ask me in the comment section If you also have a better solutions regarding this challenge, tell us what you think in the comment section. I hope you have a great day. Thank you for watching the video, and I will see you in the next video. Goodbye.